you've been around for a bit, you might have seen my Rust videos in the past. Some about why you shouldn't use it, some about why you shouldn't learn it, a lot about why I don't think it's the right tool for a lot of JavaScript ecosystem stuff. But one of those videos, the one I just did actually about Turbo Repo, got some very interesting and honestly fair responses. And rather than just link them and pretend they didn't happen, I wanted to actually sit here, eat some crap because I was wrong, and showcase these awesome responses from these people who know a lot more about Rust than I do. So without further ado, let's learn a bit about why I was wrong about Rust and why Go might not be the right choice for a lot of the things that I talk about here. The first response is a blog post from my old friend Yvonne, who was actually an architect when we went to school together, transitioned into CS, and is now a way better programmer than me, which is crazy, but really interesting resource. And when he links me something, I trust him. When he spun up his blog to write something, I trust him even more. The other thing we'll get to in a bit is a response from Anthony, who's on the Turbo Repo team that actually helped make these changes happen, who obviously had some responses. So let's dive in. Turbo Repo rewrite, the right choice? Well, balancing act. This is a fair starting point. There's been a lot of talk about hype-driven development lately, often targeting the decision to just rewrite it in Rust. A lot of the criticism about these kinds of decisions comes down to a pretty simple comparison: iteration speed versus quality and maintainability. These counterpoints are often intertwined, and the decision to choose a language is a highly nuanced one that takes into account trade-offs that people external to the development team might not have access to. You trying to call me out, man? Fair critique. Fair critique. Me commenting on technical decisions on a team I wasn't part of is very fair. And for those who don't know, Yvonne's in chat. A little LOL, sorry. Yeah, I deserve it. Thank you. While the idea that a feature set, along with the speed to market of a product, is often more important than the internal developer experience or long-term maintainability of a codebase is a tempting proposition, it's often not truly the case. This is a very fair point as well, where I externally am going to be upset about the features and the speed of iteration, but there's no way I can know internally what that experience looks like. In fact, this is a critique I give a lot, especially when we're talking about things like game dev, where gamers don't know shit about programming at all, and they assume crazy things are just easy. Like, why don't you add 4 more maps to your game? It can't be that hard. Why don't you just add 5 new game modes? Why don't you just support hundreds of players instead of 10 in a lobby? All those types of things are actually really difficult to do. And I might have done that here. Let's dive in and see if I did. Theo recently released a video about the Turbo Repo rewrite from Golang to Rust. In that video, he mentioned that the rewrite was not necessarily a great idea. I didn't say it wasn't. I said I have reason to believe it isn't. Because in the first 4 months of the Turbo project, it had the same, if not better, functionality than it does now after spending 15 plus months transitioning it to Rust. His point is that it's often better to iterate quickly on a product rather than spending time on improving the internal codebase and rewriting a product for minimal improvements in speed or efficiency. This is a fair way of stating what my belief was. And honestly, I'm still leaning that way. I think the flexibility something that Go provides you is not worth the trade-off unless you have a really good reason for it, especially since like the gap from TypeScript to Go is so big that the gap from Go to Rust in capability and functionality, is specifically in performance, is just not there. He has a point. There's a lot of history and evidence to back it up. There we go. Thank you, Yvonne. The engineering culture for products at companies like Meta and Google holds strongly to this belief, and many engineers agree with that sentiment. The Lean Startup by Eric Ries praises the idea, saying that it's better to get early feedback on a product and iterate quickly rather than optimizing for a future that may not exist when you get there. YC's Startup School also reiterates this in several of their videos and articles. So they're all fair points, make a lot of sense when you consider where they're coming from. I would go even further with these things. I think the benefit of being flexible is not just that you can move faster and get to the right place faster. It's things like responsiveness to critiques and feedback. When somebody says, hey, this thing isn't working, some technologies make it easier to re-implement, some technologies make it harder to re-implement. When it comes to things like contribution, a language like Rust is going to be a bigger learning curve for me to go make a plugin for than something like Go. It's important to consider agility, not just in terms of the team building it and how quickly they can ship the first version, but the whole feedback loop and how the community as a whole is involved in it. It's not just shipping the product. It's so much more back and forth that I think is really important too. Overall, though, fair way of stating my beliefs here. Also, the Y Combinator call out, yeah, they're really big on this too. Just ship. So many people spend so much time theorizing, planning, and speccing, and then never end up shipping anything. But we're not here to see how Yvonne agrees. We're here to see how he disagrees. So how did he disagree? Well, because it's not always that simple. For certain products, like many web and mobile apps, this strategy makes a lot of sense, and it's often the right approach. When you consider the set of requirements that a project like Turbo Repo has, other considerations come into focus. Turbo is an infrastructure tool. According to their website, Turbo is an incremental builder and build system optimized for JavaScript and TypeScript while also being written in Rust. Planning the development of infrastructure tools often has to consider many different conflicting requirements. Much like making the impossible decision between availability and consistency when designing distributed systems, infrastructure problems must make an impossible decision among requirements for feature iteration, API consistency, avoidance of undefined behaviors, cross-platform stability, and much, much more. Often, a balance can be struck in complex software systems that nicely solves for most of the requirements, but sometimes concessions must be made and something has to give. In the case of Turbo Repo, that something was building a more maintainable system at the expense of development time, adding new features and the quick availability of the tool. Interesting. I think I see where you're going, but I would make the argument that infrastructure isn't always a thing that is super stable and focusing on availability and consistency. There's a bar that has to be hit here, especially in the case of something like Turbo, where if you do a minor update and your builds stop working, that's horrifying and obviously needs to be addressed. The other side of this is that infrastructure is a very vague word that has very different meaning depending on where you're saying it. And in a place like, I don't know, JavaScript, where double equals means the wrong thing, and constant doesn't mean a constant, the level of flexibility and also the level of churn in the space is so high that keeping up with it is a defining characteristic of good JavaScript tools. We just filmed a video about all the crazy stuff happening with React, specifically in React Native and Skia, the rendering engine. And that level of flexibility and interoperability comes from how these tools were built to work that way. My concern was specifically that to keep up with the mess that is JavaScript, a lot of concessions will have to be made. And that Go's flexibility makes those concessions easier to make. Whereas a system like Rust doesn't like concessions, fundamentally. Rust wants everything to work correctly. And once you opt out of the borrow checker, you're writing a weird syntax for C. And that's an important point. And I think my concern lies more around that level of flexibility is necessary for these tools to not hold back JavaScript. I have a weird example of this point, and I'm going to get some shit for it because I'm going to talk about another language that's held back JavaScript in the web. And it's not one you would expect. It's TypeScript. Yes, my favorite language, the one I'm known for advocating for more than anyone else, is in a lot of ways holding back web tools and technologies. Because now there's this expectation that type safety just exists in the tools and technologies we use. And if somebody makes an alternative to a tool we like that isn't type safe, when the one we're using right now is, it doesn't necessarily matter how much better that new solution is if it isn't or can't be type safe the way we expect it to be in TypeScript. There's a lot of ways to do type safety that aren't really compatible with the TypeScript model either, which is an important detail because if you're solving a problem in a way that can be done type safe, but TypeScript doesn't want to support, you're shit out of luck. And that sucks that a tool like TypeScript is actually hampering some of the types of innovations and solutions people want to build in the space. Like I know, for example, the Solid.js framework has made a ton of concessions because the solutions they had were way harder to do good type definitions for than other solutions that might look a little more obvious syntactically, but are way less flexible and capable. This is worth it for the ecosystem win that is type safety in all of our development environments. It exponentially decreases the number of stupid bugs we write, and the quality of the code that we're writing overall has gone up. It's also introduced a ton of build tools and technologies we need to just make our code run in the first place because you can't run TypeScript in the browser. And it's also limited what we can do with JavaScript and the flexibility we have in that world. But that was a trade-off that as a community we decided to make, and now the majority's over the hump, the burden has fallen almost entirely on the maintainers. And as someone who has built a lot of apps with TypeScript and a small number of packages with TypeScript, I'm telling you guys, app development's way easier with TypeScript. Library dev, comically harder. Comically harder. I bring this up here because right now, the Rust rewrite of Turbo Repo, as well as the Rust implementation of Turbo Pack, are building around existing expectations around these tools and technologies. All of these things have the specific goal of taking the solutions that we have now and making them way faster. It's going to take way more effort. Let's say theoretically it takes, and this is an intentionally low number, let's say it theoretically takes 3 times more effort to rewrite Webpack in Rust than it took to initially write it in JavaScript in the first place. The problem here isn't that it took 3 times longer, because if you're willing to invest the time and money to do that, awesome. A+, do it. The issue here is a little more subtle. It's that the years of innovation we saw with Webpack and with new ways to bundle things like SVGs, TypeScript, JSX, Vue, all these other things, that gets a little more complicated when trying out these new solutions requires you writing a bunch of Rust code, especially if you're just a JS dev that had an idea for a way to load an asset differently. And now you will not get that supported in TurboPack specifically, unless you learn enough Rust to build that binding yourself. And if that process is slower, the result is that certain types of innovation just won't happen because the friction to do it has gotten too high. And that is a big concern I have with these types of changes, is that we've relied on the web ecosystem evolving because the tools we use to build the web ecosystem and the tools we use to work within it have had so much overlap that I could take my JavaScript knowledge and use it to build some tools for Webpack and build a plugin, and those skills transferred over decently well. Not great, but well enough. If I was using TurboPack instead, which was all built in Rust, the amount of onboarding I have to do before I could even start contributing is insane. And I'm concerned about the innovation we might lose, similar to the innovation that we've lost because of TypeScript. And the writer of the article already respond, okay, this is definitely fair. Rust development does require a bit of shifting and thinking, but I would argue the shift is net positive. I think it's hard to call it net positive. I would say for the individual, yes. If that individual is able to learn these new patterns and become a better dev as a result, awesome. But if they don't have the time to do that, then the whole ecosystem loses because the thing they wanted to try building doesn't get built because they don't have the ability, time, or resources necessary to invest in themselves to build this new skill, or even just the interest. They might not want to learn Rust, and now whatever they wanted to invent will not happen as a result. Apparently, you have dropped more messages, which does not surprise me. I think you see what I'm saying, but you're not sure you agree. You think modifying Rust code bases is not as brutal as it seems from the outside? I would say that this is an interesting point. The DX that Rust provides is better than Go. I would say that the confidence specifically, and confidence is an important part of DX, that when you type something, it's going to do what it says. This is one of the reasons I like TypeScript so much, because it's pretty hard to write TypeScript code that passes your type checks if you have strict enough ones, that just straight up bombs when you actually try and run it, unless you're doing something obviously wrong with your logic. In Go, it's a little too easy to write code that looks totally fine and just silently fails in terrible ways. That I fully agree with. But there's also benefits to that level of flexibility that I think aren't fully being accounted for there. And also, much like infra, DX is at best a vague term. It's much better in either language depending on what you're building and the context you're building on. Also very fair, Anthony. Who, again, Anthony's the person contributing to Turbo Repo that's helping do these changes at Vercel. So he'd have more context than almost anyone here. Let's go back to this article. It's actually really good so far. I want to be clear. I'm not trying to say that every project needs to follow suit, nor am I saying that Rust is the best language for every project. If you're building a full-stack progressive web app and need fine-grained reactivity, you might want to use React and TypeScript where the backend and frontend are tightly coupled. Not fine-grained reactivity. You're going to get a lot of flames from non-React devs, and people aren't in the React world for calling React fine-grained. It's blunt hammer reactivity would be the best way of putting it, but I get what you're saying here. You might want to use React and TypeScript where the backend and frontend are tightly coupled. Yeah. Thank you for the shout out. We appreciate it. T3 Stack for life. It's maybe not the best place for a language like Rust or Zig or Go. But if you're building a tool that's going to be used on many hundreds of thousands or even millions of machines across many projects where a developer might not have the latest version, because let's be real, we all forget to update sometimes. Also, fair point. Stability is extremely important. Breaking API changes cost a lot of money, time, frustration, and can lead to massive churn. So often, after an architectural decision has been made, even if it's found to be substandard, projects need to stay the course. Oh no, I'm having realizations I don't like. The way to offset Go's inherently less stable outputs is unit tests. The only way for Go to even come close to a Rust code base and stability is to write a shitload of tests. And in order for my stance to hold here, I have to come out as more pro unit test. And on one hand, my frustration with Rust and how bad its compile times are and how much it slows down development is now conflicting with my deep disdain of unit testing. And I am thankful I don't have to resolve this conflict, and I'm going to leave it to y'all to do instead. We've seen this in so many cases. For example, in the case of Rust's async model, even after all the time spent on it, there are architectural changes that could have been made that would have prevented a lot of headaches. According to Boats, I'm just assuming he's a Rust contributor. Let me know if I'm wrong with that. So this is a shout out that Yvonne made about the crazy history of async in Rust, which if you've heard Primogen shout Tokyo enough times, you know is not as simple as one might want it to be. I'm not saying async in Go is perfect. In fact, quite the opposite. I think the channel axioms are straight up brain dead, but it's a little bit easier. Just a little bit easier to do. Yvonne sent a great article about how async does and doesn't work in Rust. If you want to check this out, very useful to get an idea of how blocking and non-blocking code behaves in the language. And also, good old Tokyo shout out, everyone's favorite. I'm happy Yvonne pretty much entirely agrees with me on all of these points. As per usual, when you take specific words out of context for a thing, it can sound like you disagree with something when you actually don't. And as per usual, Yvonne and I are almost entirely aligned. I just went a little two balls to the wall saying Rust is the wrong choice. And he went a tiny bit two balls to the wall saying it is the right choice, where I think reality is simply, what does your team need? And also, more importantly, what does your team want? According to Boats, The intention was that users writing normal async Rust would never have to deal with the pin type at all. But there have been notable exceptions. Almost all of these would be fixable with some syntax improvements. One such exception that's really bad is that you need to pin a future trait object to await it. This was an unforced error that would now be a breaking change to fix. Yeah, I will say more languages need to be willing to do breaking changes in general. And this is definitely one of those cases. I would be hyped if Rust did a breaking change and overhauled their async stuff. I will argue, in terms of unforced error, I think we're too used to the browser model of compatibility where like breaking changes to JavaScript are bad because you have no control over how JavaScript runs on different platforms. If all JavaScript was compiled, like as a guarantee, then we'd be able to introduce new features a lot more effectively. And we'd be able to deprecate old ways of doing things. But since that's not the case, and since browsers can be using any of many different versions of JavaScript with any of many different weird quirks and behaviors, and since all of these are separate parties that are implementing it entirely independently, it's basically impossible to deprecate things in JavaScript. That's not the case if you own everything. If you own the runtime, the compiler, the binaries, the ecosystem, you can just do a major version bump and fix these things. Just do it. Make it a happy-ish path to get out of these problems, but you can solve this. I don't like that this being a breaking change means they won't fix it. I want to look at the syntax a little bit though. Do they have examples in here? No, I don't know Rust well enough to actually showcase source code about the async stuff and not just look like a dumbass. So I'm going to skip that part and let the viewer, if they want, go research it further. Rust, by the way. Full disclosure, I'm a Rust dev who's been using the language in production systems for several years. But even though Rust is my language of choice, my company is built on Next and TypeScript, with only some critical components written in Rust. Why? Because, like I mentioned at the top of the article, iteration speed does matter. And in our case, given our requirements, we need early feedback and short iteration cycles. This is the piece I felt like was missed earlier. Hope you called it out here. Iteration cycles, the ability to make changes really effectively and meaningfully, super important. The interesting thing about the Turbo Repo case is that even though Go was a sufficiently powerful language, the expressiveness of Rust enabled the team to model the required behaviors in a much more maintainable and consistent manner. One of the, albeit small, examples they mentioned in their blog post is the model of the package graph. In the Go implementation, package names in the workspace root were stored as strings. The workspace root was designated as a magic string of // and all subdirectories were modeled in relation to that magic string. In the Rust implementation, package names in the workspace root are modeled as an enum. Rust's enum type provides a powerful pattern matching mechanism that allows them to define separate variants for the workspace root and for subdirectories. This is a nice example where root should be treated differently and it ideally should be typed differently as such. As they go on to say, not only is this more efficient, it also ensures correctness. Rust's enum types greatly facilitate maintainability, and modeling this sort of thing is super easy to read and understand. I believe that for Turbo, efficiency and correctness are some of the more important requirements. I will say that seeing enums greatly facilitate maintainability as a TypeScript dev is kind of funny because enums in TypeScript do not make things more maintainable. They make subtle bugs much easier to commit. So it's nice to see other languages, I should say most other languages, use enums correctly. Before we go into the other considerations, I think this is a good point to bounce over to Anthony's response because this includes a bit of it, but I want to show the whole thing. Slack made this very hard to do because Slack makes most things harder than they should be. That's just kind of the nature of Slack. So we'll be doing our best to read a bunch of screenshots here. I am sorry in advance. This is again a message from Anthony, the guy who made a lot of these changes over at Vercel. I think he has really good context here and kind of shut down some of the dumb things I said in my video. Yo. I know I mentioned some of the story on why we slowed down during the Rust port while we were talking. More follow-up here so you caught the whole scoop. I know you said you already recorded, but in case it helps. I did, and I published, and now I have to talk about. 1.7 was the first release with Rust in it, and looking back at release dates, things were slightly slower during the porting window, but not by much. Kinda had to squint to see it. First point here is that there was important features in every single release during the port. It was important to us that we kept delivering value during this port, and the reason that we accepted a ton of difficulty. There were easier ways to go about it, but we picked the ones that let us keep releasing the features that people wanted. The last leg from 1.10 to 1.11 is the 6-month gap. Oof. Like I said, there was a ton of parental leaves during that time, and it was the most difficult part. That's also very fair. Something I hadn't properly considered in the past is that when a team has multiple people leaving because they're suddenly parents at the same time, that's going to cause slowdown. And that slowdown probably accounts for way more of the pacing changes that I saw than anything with the language changes. Important callouts. Really unfortunate timing as far as software is concerned, but glad the parents got the time. Yep, absolutely. Never want to shame a parent for wanting to spend time with their kids, even if it means that my JavaScript doesn't get built quite as fast. Absolutely had some mistakes in execution that slowed things down. It is what it is. Extremely difficult to get stuff right. Yep. There were some feature deprioritization choices that we made specifically because we knew that they were going to be so good in Rust and Cheeks in Go. This is also a very interesting point, that there was features they didn't want to implement when they were still on Go, and they were waiting to have the Rust build first and foremost so that they could build it on top of Rust instead, because it'd be a way less miserable experience. We could have shipped more things, but consciously didn't, thinking more long-term. So we got the Arch and the Vim, by the way. The features slated for the next couple months should be massive, including a brand new TUI that will blow the doors off of what we currently have. Terminal UI, by the way. If you do a Rust don't ship narrative, it might look kind of funny after the stuff that's going to come in the next few releases. Please, for the love of God, make me look funny. I really want Turbo Repo to ship more, and I want TurboPack to work. So please make me look funny here. I've just been waiting for a long time for these things to improve, specifically for TurboPack to be viable. So yeah, prove me wrong. The amount of bugs being reported has gone down dramatically, and when they come in, they get fixed so much faster and without producing more bugs. This is the point that was so big to me that I really wanted to make this video. When I read this bullet point, I was like, okay, fine. If they honestly believe that they're able to identify and fix bugs significantly faster and the number of bugs they're shipping has gone down, fair. I can't talk shit about that. Period. Good shit. That is awesome to hear. The last part is a stark difference from Go for our use case. We played a lot of whack-a-mole. Yeah, the one part I would counter here is that the second implementation of something's always going to be significantly better and easier to maintain because of everything you've learned. In your case, it was also weird because there was lots of behaviors in Go that you couldn't just replace in Rust. You had to re-implement in order for backwards compatibility. So even though you had the knowledge of building this before, helping you build it more effectively the new time, you also had the cost of having to implement those weird behaviors from the past too. I don't know how well it balanced out, but you absolutely benefit from rewriting a thing, so much so that you will have code that's easier to maintain and debug and work with because you don't make the mistakes you made the first time because you know about them and you can dodge them now. As someone who's rebuilt a lot of things a lot of times, yeah. Anthony actually just replied to that point saying, this is something he thought about after he sent the message. Attempt 2 is better 99% of the time. Very true. Yep. Cool. We agree there. We honestly got a little worried that people stopped using Turbo Repo because issue reports dropped off a cliff, but a quick check of NPM downloads and community trends proved otherwise. Pretty cool to see. It's crazy that the number of bugs going down was so big that you were concerned there was less usage. Again, that's a thing that happens over time with stability, but I understand the concern. So yeah, all in all, looking back at it from my seat, 95% win. Trying to not sound like an apologist, if it would have went terrible, I'd be the first to say it. But hopefully some pockets of context there that you probably wouldn't have otherwise. Yes, it's also context that my audience would have otherwise. So thank you for giving it. It is actually very, very valuable. I want to make sure this is reported on fairly. I just want my build tools to be faster, and I'm seeing all of this effort where people are talking about the languages they're using for these tools and not about the features they're adding to them. And I'll be honest, I feel like I've heard more Rust, by the way, from the Turbo team than I've heard, here are the cool new features that we're adding to these things, by the way. That's where my concern comes from, is this deep-seated feeling of, why are they talking about programming languages so much? I just want my JavaScript to build faster. This is a good point from Nifran. Hopefully I pronounced that right. Quicker bug fixing could be thanks to the source of truth being in types in Rust, where it's spread out through unit tests and docs in a Go code base. Yes, source of truth being contained is a really important thing for fixing stuff. Funny enough, this is one of the reasons I like Tailwind so much. I know it's weird to go in the Tailwind direction when we're talking about Rust, but hear me out for a second. With Tailwind, your styles are almost always right where the thing that is having a problem is, because your styles are inlined inside of your components in your UI layer. That relationship makes it way easier to identify where an issue is happening and fix it. The amount of steps and places I'd have to go to debug weird CSS issues before I started using Tailwind was one of the reasons I hated CSS. I had so many crazy issues where things would work in dev and not in production because the order that styles came in was so fundamentally different sometimes, where certain styles would load faster in the production build, other ones would load faster in the dev build, and the order they load in changes the way that they apply. These places that are spread out like that are different sources of truth that I have to mentally organize before I can fix the problem that I'm seeing. With Tailwind, I just go there and I fix it. If the source of truth for Go is between your unit tests, your docs, and an arcane history of pull requests and things people have reported in the past, that's a lot harder to fix. Whereas if you're using Rust and your expectations are encoded in the type system, you probably don't have to go as far from that thing in order to fix it. And as per always, we get the sounds like spaghetti comment. Spaghetti is a very efficient way to eat compared to having a bowl of water, some flour, and a bunch of other random stuff on the side. If I had to choose between eating spaghetti and eating a bunch of flour and water because it's all spaghetti on the inside, like, no, fuck you. I'm going to eat the spaghetti. Yeah, I will never like these comments. And it's funny to think that you could flip my last Tailwind drama video to be about Rust, and it kind of makes sense here. The other issue with this all, though, which I'm sure we'll get into some out in this article, is the fundamental reality of that once you've encoded things that tightly, sweeping changes are more difficult. Like with Tailwind, if you wanted to fundamentally change the look of your site, if you wanted to do a from the ground up restyling of your site, you don't have one CSS file you can go make changes to do that because the CSS is so deeply intertwined with the markup. I think those types of site-wide rebrands are nonsense and leave more problems than they solve. But this is also kind of the case with Rust, where if you build something in Rust and it turns out you want to fundamentally change like the API or the behaviors or the way we expect it to work, it's usually more efficient to just start from scratch than it is to slightly change things over time. Where with Go, it's flexible enough, or even JavaScript or old school CSS, all of these things are flexible enough that you can pick one part, tear it to shreds, plug it in, have some bugs, fix them, and then move on with life. That is not the case with Rust at all. And you can ask anybody, even Primogen, about the misery that is rethinking a structure of a Rust code base, because the type system so deeply defines the expectations and the behavior of things that when those things change, you're just kind of fucked. There are other considerations that I don't want to go into in fear of an overly long post, but they're detailed here. FFI with languages like Go can be pretty difficult. Go's concurrency model and green threading makes concurrency simple when working within the language, but it's harder to manage across inter-language communication. This is by design. You can call C from Go, but it's much harder to call Go from C. So that's what we have Zig for, to just messily compile everything together so we can call it to and from. And mostly joking, this is a fair point. Like, Go kind of assumes it is the bottom of your stack and that you're not going to be calling things like that. This is a fair critique, and I'm surprised that only Zig seems to be really focused on making this balance work out. Although, again, Go has its concurrency issues too, which I won't dig into. Check out Faster Than Lime's blog post about Go if you want to see the problems there. The abstraction layers that Go provides over system calls are convenient, but for a bundler and build systems like Turbo, low-level control over things like the threading model and other system functions is important. Not to rust all over you, but CFG attributes make platform-dependent compilation much more maintainable and the code separation much more understandable. This is another fair point. Most technologies don't target Windows great. I know Zig's a bit rough there. I know Go's a decent bit rough there. Like, it works, but it's not great. Rust, I've heard, has a much better overall Windows story. So having platform-dependent stuff built into the language to make it easier to compile these specific platforms, that's a good win. And I can see why when Turbo is trying to target every platform, those things are important. Garbage collection's a wonderful, sneaky double-edged sword. Go occupies a space where avoiding the GC is a bit convoluted, requiring manual minimization of heap allocations. I don't think this point is particularly valid here. I think for long-running services and systems, garbage collection absolutely can slow things down. Discord made the switch from Go to Rust in 2020, and a big part of it was the garbage collection issues they were seeing, where they would have these crazy CPU spikes because garbage collection was happening, and those spikes would happen on like a timer effectively, causing responsiveness to go down terribly. Since then, Go has significantly improved their garbage collection and how it is managed. It's way smarter. So I would expect if you just took their old code and threw it in Go instead, that it would probably be fine at this point. Not great, but significantly less chaotic here. But if you really want to optimize for every response consistently, not the right language. But when you're talking about a build tool that runs for a fixed amount of time and an individual spike isn't a big deal for, I really don't think garbage collection benefits compilers at all. In fact, to go back to the point I keep hammering on about here, having to optimize for those types of things is taking time away from other more important things. Like in this case, having good concurrency where things interoperate well and using whole of your cores is significantly more important than how you allocate and deallocate memory. Because in this case, we have a ton of files as our input. We want to make a compiled smaller bundle as our output. That's not a case where memories and things you should be worried about that much. And if it is, you've probably screwed up something else. Oh boy, a Zig point. Enough yapping about Go. What about Zig? Well, although Bun is written in Zig and doing phenomenally, I might add, yeah, Bun is consistently impressing me. I'm still surprised at how much I've been able to adopt it. Long tangent. Anyways, Zig's still only at version 0.11. Bun is making a juggernaut bet on the stability of the API and the progress of the language. Yes, in fact, there are concerns on the Bun side of accidentally bullying Zig into certain directions and trying to find the right balance of letting Zig be its own thing separately and also making sure the design decisions and changes they make to Zig don't hurt the biggest Zig user by far, which is Bun. Interesting balance to figure out there. Zig version 0.12 introduces many breaking changes, including overhauls of the standard library. Zig's async features have also regressed. They are not present in version 0.11 and likely will not be present in 0.12 either. I love Zig. It's one of my favorite languages, but it is nevertheless a risk. I would absolutely agree. Zig is a way riskier bet than any of the other tools we're talking about here. Go, TypeScript, Rust, Java. Zig's a bet. Depending on how you're using it, that could be more or less risky. Like the way Uber used Zig or the way TurboRepo used Zig as a compiler layer, that isn't something you have to worry about changing too much, and you can stay on an old version for a while and be fine. If it's just a nice to have win to improve your interop story, and you're not actually using Zig's API and language that much, you're probably not going to be affected that much. But if you are writing everything in Zig and they make significant changes, you might be fucked. But as Yvonne just said in chat, Zig's compiler is unparalleled. Yes. And as Anthony just said, they only used the Zig binding for a couple months, and now they're fully exited from it. It's really cool. It's also unparalleled. Does it run parallel, though? Or does it have to be single-threaded? Hopefully it runs in parallel. Anyways, conclusion. The point I'm trying to make in this long-winded post is this. In some cases, I think the Turbo example is one of them, error avoidance and explicit behavior modeling are the driving factor behind architectural or language decisions. Another tangential, semi-unrelated, but still important point here is that language choice has an effect on developer experience when working on a project. Rust is fun to write, and working in a language you enjoy makes a project more rewarding to work on. I have not experienced the joy of Rust, but I absolutely know this is a point that a lot of people make, and I can't doubt it just because I've seen so much of it. What I can say with confidence is that I've never enjoyed myself writing Go. I've written enough Go to confidently say it's not a language I will ever enjoy, but it works. It is easy to work in, and it's really easy to code review. So those are the differences there. Is Go trades fun for consistency and simplicity. It doesn't make you feel smart, whereas Rust absolutely makes you feel smart, but it also comes at the cost of you having to get smart enough to experience that. Rust is fun to write, and working in a language you enjoy makes a project more rewarding to work on. Let's be real. Hype-driven development is a very real thing. The rewritten in Rust phenomenon is funny on Twitter and X, but it's also a valid marketing strategy. An important point with this too is how much these things hype up the development team. Something I've learned over my time managing teams is that sometimes you just gotta let them go do the stupid thing, even if you know it's going to fail, because there's a slight chance you're wrong and they are actually faster. But more importantly, like much more importantly, the hype they get from doing that, even if it does fail, will accelerate your team meaningfully. Having devs that know you trust them to make those types of decisions, even when you disagree, letting them invest in these things and invest in themselves and do crazy stuff with it, that gets them more hyped and it keeps some of your best talent around. Because the devs rewriting things in Rust are not lazy Linux neckbeards that suck at programming. They're some of the most talented developers in the world, especially the ones with anime profile pictures. Those developers are ones you don't want to lose. And if letting them waste 3 to 6 months on a rewrite is the way you keep them around, for that reason alone, it's often worth it. I'm not saying Rust is bad at serverless. I'm just saying it's worse than JavaScript. Its startup times aren't much better, especially when you consider some of the things you can do with these new runtimes, especially when you consider things like edge runtimes and what Cloudflare is doing. It's just the state of the ecosystem for JavaScript and the speed at which things can respond is insane. If the primary cost of your response times is the code you're running, Rust will absolutely be a win. But if your goal is to get a response to a user as fast as possible, and more of the time is spent on the cold start than it is on the actual time to generate a response, which is the case for a lot of the use cases for serverless, JavaScript often ends up being significantly better. The main idea I wanted to leave you with is that choice of a language, tool, architecture, etc. is a highly nuanced topic. I don't think there's really a perfectly right answer. Engineering teams need to carefully assess requirements and make decisions according to the project's needs and long-term viability. No one can prescribe when and where to use any language. Every software system is different and comes with its own unique set of challenges. That's part of the fun of it all. I actually don't necessarily agree with this takeaway. I hope that the point people took from my last video wasn't rewrite your Rust code and go, because that was never the point. My point was much more specific. It was that doing these rewrites is rarely worth it, and you need really good reasons to justify it. I think the best language for the job is almost always the one that the team's already familiar with. And if it isn't, then the next best language is the one that solves the problems you had with the first one that is the most similar to the one they're already familiar with. And I think that's why I disagree with this so much, because if we're talking about absolutes. Like, what is the perfect language to solve this problem with? Cool, A+. Like, that's a fun, nerdy conversation to have. But the goal of my video wasn't so much to say Rust is wrong, Go is right. The point was more to say, I don't see the value of everyone rewriting everything in specifically Rust right now, especially when we're seeing success with Go rewrites instead, where rethinking our build tools like Babel with something like ESBuild, written by one dude in Go in a couple weeks. It feels like we've been trying to catch up with where ESBuild was a month into development for years now in the Rust world. And my concern was never that Go is right, Rust is wrong, we should all be writing in Go. It was more so that I felt like we were chasing this dragon of the perfect language. And that's the specific thing I wanted to fight against, is the point that's being made here. I know this isn't about me and my video specifically, but I don't like the idea that we should be seeking the perfect solution to our problem. I think when the solution we have now starts causing different problems, that's the point to move off. And the specific point I was trying to make before was that JavaScript's obviously the wrong tool for the job because it's causing our builds to be way slower than they should be, especially if you're still using Webpack in the year of 2024. I am so sorry. Moving off it required something faster, not the fastest solution. It required something maintainable, not the most maintainable solution. It required something familiar, but not perfectly familiar. And I think Go was a really good compromise that we skipped past, was the specific argument I was trying to make. Overall, though, this is a great article that really showcases why Rust would be a good decision for these things. Again, assuming the team wants it. If you're a team that is currently stuck in Go, wants to use Rust, and has actual benefits that you get from it, like when Anthony cited that there were features that were easier to work on in Rust than in Go, or that they've had a significant shrinkage of the number of issues they're seeing opened. Those are real benefits that if those are problems your team is suffering from and they want to use Rust, makes a ton of sense. My argument is simply that you shouldn't jump languages for the sake of it. You should do it with a reason in mind. And if the reason is so that the devs are happier, cool, but you need to say that part up front. And I simply have concerns that we've went too far in the Rust direction because the place we were at before of everything's in JavaScript was terrible. Terrible, terrible, terrible. There's so many things written in JS that shouldn't be. And I'm saying this as a JS Andy. But the solution there isn't to fully escape and go to the other side of the spectrum. It's to take steps out of where you currently are until your problem is solved. There's no such thing as perfect, and I'm tired of us pursuing it. I just want things to be better. And as much as I have shit on Go, I do think it is a lot better for a lot of these types of solutions. I think that summarizes my point here pretty well. I don't think Rust is this terrible language. In fact, I actually think Go is a worse language than Rust. Don't tell anybody. It's certainly not Melky. But the point here is more, I think we went too far all at once. And I want to make sure that the teams make decisions based on what they want and need and the problems they have. So if you really want to use Rust, absolutely do it. I'm just sad that it feels like the web ecosystem is moving slower because of it. Please, 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 please prove me wrong. I would love to see all of these Rust projects start shipping way faster and for all of us to have Rust in our build chains for our JS. But right now, I still find myself relying a little bit more on tools built on Go than I do find myself using tools built on Rust. That's all I have to say on this one. Until next time, peace nerds.